let it develop there. Today I want to show you one of my side projects. I think it is quite interesting, but before we start, let me show you some photos from it. Those photos should tease you, so you can be excited about that video. So let's start. This is the salt lamp. You can buy similar on the Amazon. Usually it's done with a regular lamp, and I want to put the LED lamp in there and make it work from USB. This is the prototype board. I want to screw it like that, and the lamp should produce light and do its salt things. This is the LED board. I want to use LEDs like that and make a thermal control for it. That's it. Let's check this schematic. Okay, let's check out the schematic I want to use for this. It is based on 555 timer. This is the timer, and we use the NTC thermistor with 100 kilo ohms in normal temperature. And let's try to run a simulation and check what's happening. As you can see, when the thermistor is 100 kilo ohms, our output is working at nearly 1 kilohertz and 95% duty cycle. And when the temperature in the lamp increase, the thermistor is reducing its value. So let's try to reduce the value, and you can see the duty cycle is also reducing at this point. And side effect, one of the side effects is that it increased the frequency, output frequency, but I'm okay with that. And when the heat builds up, our duty cycle is reducing. You can see the current duty cycle is 83. At some temperature, our duty cycle should be stabilized by current temperature. And one of the interesting part that if heat continues to build up, and duty cycle can reduce down to half of starting value, and now it's 54% and 5 or 6 kilohertz. And when this system has overheat protection, if the temperature continues to build, at some point it shut down the output completely, and our device cannot overheat at all. Let's check at which moment this function starts to work. As you can see, at 8 kilo ohms the system is disabled, and at 9 kilo ohms the system begins to work with 38% duty cycle. And if we check our datasheet for our thermistor, we can see that this resistance should be when temperature is around 90 degrees, and I think it's a good value to prevent overheating for this device. So let's return to our breadboard and try to experiment with this. Here is our breadboard, and we want to use it, and here is our components for this schematic. One last thing before we start, let's check our components, that they are okay, and basically ensure that we won't have any troubles with them. I decided to fast forward this process so you don't get bored. Basically, I'm using this transistor tester and check each individual component that it works okay and fits the specs. But I haven't checked this 555 timer, but I think it should be okay. Our device is powered by 5 volt, so I already set 5 volts in there. I've improved this breadboard so it's adjustable, it can give different voltages. Okay, we have set up the power rails, setting the reset pin, installing the capacitor, and I think it's not the best place for this capacitor, so I moved it a bit to second leg. The resistor, 5.7 kilo ohms resistor. The yellow wire is an output wire. Here I'm trying to find the best place for the diode. I'm already excited about this device, and I'm not alone. Oh, who's there? Okay, this is the 100 kilo ohms thermistor. We set it to the breadboard. Now the device looks complete. Let's try to turn it on. I close it to protect my eyes. Let's try to check temperature, if it's heating or something. Seems nothing blew out, so at least first test has passed. Now it's time for my toy oscilloscope. This is my toy oscilloscope, but I think it should do the job. Let's connect the ground wire and hook it into ground of oscilloscope. Let's check what's happening there. And we need to power up. This is my 9 volt battery with a special jack, and the oscilloscope boots up, and it shows something wrong. Okay, oh, now it's okay, and we can try to pin something and watch the histogram. Okay, we have the 5 volts input into our 555 timer, but we have weird output, our weird PWM signal, and we need to investigate what's going on. Let's hook it into the oscilloscope. Let's revise what we can see right now. We have the weird oscillogram, and we have duty cycle nearly 50%, and frequency about very unstable frequency. It's very strange things happening. Let's try to check what's going on the capacitor. It's also a weird signal on the capacitor, so it's very unusual, and possibly something wrong with the connections. And gotcha, I have wrong configuration on my oscilloscope. That's better. I'm reducing the time window at the moment, and the signal looks better now, because my device works at 1 kHz. Our time window should be no more than 10 milliseconds, or maybe 1 millisecond. So okay, with 0.2 milliseconds the oscillogram looks good. Let me adjust the 0 scale for measure better picture. Let's move the 0 to the bottom, and now we can see the oscillogram. I want to move the trigger level. Okay, that's done. Now we can watch the values. Current duty value is about 95%, and it's working at 1.3 kHz. Voltage is about 5 volts peak to peak, and yeah, it's working good. Now we should check it with temperature. For this I have my soldering station. Let's try to heat it with soldering iron. I want you to see the values. Unfortunately, the minimum value is 200 Celsius for my soldering iron wood. I think it should work. Let's try to heat the sensor. The sensor is heating, and you can see the duty cycle is getting lower and frequencies goes up, so device works. And if I remove the soldering iron, it resumes to normal operation. Okay, let's try again. We heat it and duty cycle reduces, and if you continue, it shoots down completely, as you can see. And I think the device is working well, and that's it. Here is the LED I want to control with this 555 timer. The 555 circuit will control these LEDs inside the lamp, and it will be thermally stabilized. And as you can see, the control circuit working great. So in the next video we will solder it into a board and put it into a lamp. So don't forget to like and subscribe.